Today we're going to talk about writing linear equations when we have practical problems, aka word problems. So we're always going to look for, we just have to read the words really and see what form of the equation we can potentially make. So we're going to look for slope words, words like per, rate of change, a constant of variation, etc. Oh, I've missed the word per in here is also important. We're going to look for Y-intercept. If we have Y-intercept, we can put in y equals mx plus b, or a point or 2 points, where we'll use point slope form, y minus y1 equals m times x minus x1. And we're going to use that information to write an equation. One thing that's really helpful when you're looking at practical problems is being able to identify what is an independent and what is a dependent variable. And we've talked about this before, but I'll remind you again that x is always going to be your independent variable. It's your input that I can choose, right? I choose, and y, or f of x, is always your output, and it's always dependent on x. And we'll look at some examples of this again. We talked at the beginning of the year about things you can choose, things you can manipulate, etc. But we might need some review on that. So we will talk about that. So this is the first problem we have. An airplane starts being observed at 30,000 feet above the ground. 30,000 feet above the ground. The plane begins descending at a rate of 2,000 feet per minute. Well, first we have to recognize that descent of an airplane is a negative word, and we are given a rate, 2,000 feet per minute. So we have negative 2,000. Assume the plane continues at the same rate of descent. The plane's height and the minutes above the ground are related to each other. So there's a couple different ways we could think about this one. We are able to quickly identify the slope because we have the word rate and we have the words per. So we know that m is equal to negative 2,000. And we are starting our observation, so at minute 0, your height is 30,000 feet. Now, we could either say we have a point that we know, 0, 30,000, right? Because we think about a graph, we're at minute 0, and as time, the independent variable, because we cannot control it, right, moves forward, the plane is going to be going down at a rate of 2,000 feet per minute. So at minute 1, we have to know it would be at minus 2,000 from 30,000. So 28,000 at minute 1, 26,000 at minute 2, and so on. So we can say, well, at minute x, 0, y, 30,000, and that's a point we're given. Or we can recognize that this anything with the x value of 0 is a special point, which is the y-intercept. So we can just write this one straightforward. Y equals negative 2,000 x plus 30,000. So we're asked to calculate the altitude of the plane after 5 minutes. So remember that minutes, as we ticked along the bottom, time is x. So everywhere I'm given x, I'm looking for y. So everywhere that I see x, I'm going to use 5 instead. And after 10 minutes, the plane, 5 minutes, the plane will be at 20,000 feet. 1, 2, 3. Now, I did tell you there was another way you could have done this problem, which is that you could have recognized that you have a point, 0, 30, 1, 2, 3, and a slope, negative 2,000. And you could have used y minus y1, 30,000, times the slope, x minus 0, distribute, and solve for y. And it's going to get you to the same place. So you'll end up with the same equation. But if you didn't recognize that that was a special point, but you were able to recognize it's 0, 30,000 plus 30,000, then you would get to the same place so that you have the same equation. All right, let's try another one. Marty is spending. Spending means going out. So is this a negative word or a positive word? This word is negative, so minus. At a rate, there's your slope term, $3 per day. So your slope is negative 3. After 14 days, he has $68 left. So we have said before, time is always going to be x. So here, x is equal to 14. And then we have the amount of money. We can probably guess that that is going to be y. Because if you read, the amount of money he left depends on the number of days that have passed. So if we're going across the graph like this, the amount of money he has is going to change as time moves forward. At 14 days, he's at 68. Okay, so identify the slope, which we've done. M equals negative 3. And remember, I wanted you, as I told you guys in class today, you needed an x1. Well, we have an x1. x1 is 14, and y1 is 68. Okay, and that is your ordered pair. It's 14, 68. So can we write the slope-intercept form of the equation that models that situation? Well, we have to start in point slope because we do not have a y-intercept. So everywhere I see y, y1, I'm going to use 68. Distribute. Okay, I'm not really sure what happened here, so hold please while I erase this. And I'm going back. Hold please. Think that we were here. Hopefully this makes sense. All right, so we were writing y minus 68 is equal to negative 3x minus 14. So remember that our point was 14, 68. Distribute y minus 68 is negative 3x plus 42. Add 68 to both sides. And you're left with y equals negative 3x plus 110. We are asked to determine the amount of money that he began with. So we are given x and we are looking for y. And remember that money is here, and as we move forward in time, we have something that's going down. So we are asked to look for the amount of money he began with. That means we are looking at time 0 right here, right at the very beginning. What happened at the beginning? Well, I go back to my equation, and everywhere that I see x, instead I'm going to use 0. You might even call this f of 0. Remember that function notation? Plus 110, 3, negative 3 times 0 is 0, and y is equal to 110. So he started with $110. And this is the last one we're going to look at. And this is a 2-point example. So suppose a 5-minute, we have a time again. So what do you think that's going to be? Well, time is usually X, right? We have a 5-minute overseas call that costs $5.91, and that's an amount. So that's usually dependent on the amount of time. So Y is the amount. And here we're given another time and another amount. So if I have an X and a Y, and then I have another X and another Y, what am I given? Well, now I have 2 points, okay? So we're asked to identify the slope. Can we identify the slope? For this one, we can't, so we're going to have to calculate it ourselves using the slope formula. We have 2 points, 5, 591, and 10, 1086. Okay, so we're looking at change in Y, 1086 minus 591 over change in X. And through the magic of Desmos, I've discovered that the rate is 99 cents per minute. So now we have a slope, 0.99. Now we're asked to identify a y-intercept or a point. Well, we don't have a y-intercept. That would be an x value of 0, which would be then 0. But we do have 2 points. So we can choose either one of those points and substitute that into point slope. Y minus 5.91 equals 0.99 times x minus 5. I chose the first point. This one right here. Here's your x1, y1. We're going to distribute y minus 5.91 equals 0.99 x minus 4.95. Add 5.91 to both sides. And y is equal to 0.99 x plus 0.96. Now, how long can you talk if you have $12 to spend? So now I'm given y, because the amount of money depends on the amount of time that you speak. So I'm now looking for x. So everywhere that I see y, instead I will use 12. 12 equals 0.99x plus 0.96, and let's solve for x. Subtract 0.96 from both sides. 1104 is equal to 0.99x. Divide by 99 cents. And we have 1104 divided by 0.99, which is 11.15. So the phone company, are they going to let you talk for this 0.15? No. So we can just round down. We can talk for how many minutes? 11 minutes. Okay. I hope this helped. Thanks for watching.